Sandalakshmi, are you there?
Yes, sir. Yes.
Can we start?
One second. No, sir, we can start.
Hello.
Yes, sir.
Okay, you're not audible actually. I don't know.
1 second.
Okay, good afternoon, everybody.
Good
On behalf
afternoon.
of the Pulcheri Climate Change Cell, it is my immense pleasure to welcome all the participants over here who have joined us in today's special webinar marking the World Environment Day 2025. And I also take pleasure in welcoming our speaker, Engineer S. Sudalai, Assistant Professor of Center for Pollution Control, Pondicherry University today, who has joined us in spite of his busy schedules. Uh, the Puducherry Climate Change Cell is the nodal agency of Government of Puducherry under the DSTE, which is working on building strategic knowledge on climate change, especially region-specific knowledge, and developing climate change adaptation and mitigation strategies for the UT of Puducherry for various sectors like agriculture, animal husbandry, fisheries, tourism. Um, and also, we conduct a lot of capacity building programs and awareness programs. And I'm proud to say that we have conducted 35 webinars over the past 6 years since the inception of the Puducherry Climate Change. And through the webinar alone, we have reached to more than 4,000 participants. So the today's webinar, uh, which focuses on the World Environment Day celebrations, 2025 celebrations. As you would be aware, the theme for the World Environment Day 2025 is Beat Plastic Pollution. So, in alignment with this theme, the current year theme of the World Environment Day, today's talk will be on the topic circularity in plastics, the key to ending plastic pollution. Plastic pollution is a crisis that transcends border and affects every living creature on this planet. The plastics have affected the oceans as well as the fertile soil beneath our feet, and it has infiltrated into every corner of the environment, contaminating our food, water, and even our human bodies are contaminated. For India, also, it's currently a major challenge because there is millions of tons of plastic waste generated annually, and much of it is ending up in the landfills or in the natural environment. So the traditional take, make, dispose linear model of consumption will no more work. We need a fundamental paradigm shift towards the circular economy for plastics. Circular economy means reimagining how we design, produce, consume, and manage the plastics, ensuring that they remain in circulation at their highest value as long as possible. So we are honored to have with us our distinguished expert engineer Sudalai, who has done extensive research in the field of environmental engineering, solid waste management, and circular economy in plastics, recycling of plastics, upcycling of plastics. And he has collaborated with the government of Pondicherry, Pondicherry Municipality, Vadakkam Municipality, and also our Department of Science, Technology, and Environment in various initiatives. And he has always been supportive to the government. His insights will undoubtedly inspire us to think differently about plastics and equip us with practical knowledge to contribute to more sustainable future. Let us embrace this opportunity to learn, engage, and commit ourselves to making circularity in plastics a reality. Thank you, and let's begin this insightful session. Sandalakshmi, you can give an introduction about the speaker.
Okay, sir. Am I audible, sir?
Yeah, but it's feeble. For others, it's okay.
Yeah, it's fine, sir.
Yeah, okay. Carry on.
Fine, sir.
Good evening to everyone. We are pleased to welcome Engineer Suralai Subramani, Assistant Professor at the Center for Pollution Control at Environmental Engineering, Pondicherry University. With over 15 years of experience in both industry and academia, he began his career as a senior design engineer at L&T before transitioning into teaching and research. He now teaches and researches key topics including solid waste management, citizen science, and circular economy. His impactful work has earned numerous accolades such as the Sir Ganga Ram Memorial Award, Best Paper Awards, and a State Award for Electoral Excellence for Carbon Accounting during national elections. He holds two patents and he has published extensively in impact journals such as Renewable Energy and Environmental Science and Pollution Research. He is also an active contributor to policy and the public outreach through national workshops, beach cleanups, and government advisory roles. Let us welcome Engineer Suralai Subramani sir, whose work continues to drive environmental sustainability and innovation across India. Over to you, sir.
Thank you, ma'am. Thank you. I hope my screen is visible to everyone. Hello, am I audible to everyone?
Yeah, you can switch to full screen mode, sir.
Yes, sir. I done, sir. I've done, sir. Once again, sir. Sir, I'll switch off my camera so that it'll be easy for without any network issue. It will be displayed, sir. I hope my screen is displayed. Thank you, sir. So first, thanks for this opportunity. Uh, because we have been working for a long time, but it's a rare opportunity to display what we have been working. We work in the line of circularity with the plastics and other materials. Plastic is more exclusive things, so the impetus on circularity of plastics is placed in a high priority because the impact is huge. So I'll try to justify the moments for everyone who listen to this session. Maybe at the end of the session, you may understand why we need to switch over to circularity of plastics and other materials also. So the very right picture, what you're seeing right now is the on the left hand side, you're able to see some spoons, which is actually collected from seashore. I mean, the beach sides of Puducherry. Most of the things is contaminated with food waste, and after 2 3 days, this is how it looks like when it reaches the recovery park. So this gives you a clear picture how the circularity is challenging for us. It is not just plastic is very selective and reaching us so that we can go for a the recycling or any kind of value addition. But always plastics comes with a mixture, and that mixtures create a lot of nuisance. And it is also not common for every geography. It have unique composition in different places. So this is how the challenge is going to be. So we'll start the session. Let me go with the generic introduction, then I'll move forward to the specific topic and few case studies. That is how the flow is going to be. So first, I'll be discussing about why should we go for circularity. Then we will discuss about a different type of I mean, the generic waste definitions. Then we will move on to the plastic issues. Then we will move on to the selective case studies, which we have been doing here in Pondicherry region. So first thing is the cost of grow now and clean up later. You might heard about this particular report. This is called the Global Environmental Outlook. There are two reports you should always get into touch with that to understand why should we go for circularity. One is inequality report, other one is global environmental outlook. So the theory says that the strategies for every country to get developed is initially they wish to grow. Then they thought whatever the pollution or mistakes they do during the growth, they thought that we can clean up later. But the problem is the cleanup cost in the later stage is very expensive than the benefit we get out of the growth. So there's a theory proposed by Ekins and Zingl. I couldn't pronounce the name appropriately. The thing is, these two others, the cost and benefits of environmental sustainability. So this particular article very clearly articulates what are all the problems associated with grow now and clean up later. So the proposed strategies for growth is critically failing in some point of view. So the Natural Science in GEO, that is Global Environment Outlook, the sixth report, make it very clear that it is not feasible to grow with growth. So thereafter, we can understand the problem associated with the linear economy or the present growth patterns. So they have given some interesting pictures. The numbers have a lot of meanings in it. So the drivers for environmental changes they have taken as five parameters: population, urbanization, economical development and technology, and innovation, global sustainability, then climate change. And these are the different type of drivers which is actually driving the environmental changes. So we cannot stop population and urbanization. Both the things are going line by line. So we cannot do anything with these two. Other thing is economical development and its technology and kind of innovations we have for the technology enabling, and how it is linked with the global sustainability is another big question. So how every country takes its own development and how the emissions or pollution episodes are following it. It has been depicted in several reports. This is one such report. Every country, how much they are emitting, how much they contribute for world emissions. Like population wise, some countries are very small, but when you count the emissions, they are higher than most of the populated countries. So it's all very clear that population cannot be directly correlated with the pollution. I may be vary from the average, but this is my opinion based upon reading certain articles. We cannot keep blaming the population. It is the selective population in the whole world. Maybe for example, UK or USA, they have very less population than India. But when you talk about the emissions from their particular geography, they may be higher than us. So directly correlating the population with the pollution is not going to be a sustainable solution for us. So this report make it very clear that it is not directly correlated. And this particular report, World Inequality Report, I often repeat this particular slide because this is the starting point of where we should start the circularity. Here you're able to see a picture which is having an inverted trunk of elephant. So this considered this an elephant and it is raising the trunk. This is called as inverted elephant diagram, and this has been proposed by Christoph Lankner and Branko. So these two people proposed this particular plot. Actually they have plotted the global income distribution. This is the global income growth rate. This is growth rate, particularly income growth rate. This is percentage of income distribution. So it means that this is richest person. This is the poorest person. As such, the data says there is no poor person in the globe. So the lowest person itself have some amount of money. So it starts with the it's not starting with origin. It is slightly above that. So the poorest person itself have the growth of 15 to 20 percentage, and the rank wise, if you go here, the richest person, you can see the highest growth. In between, there is a space, and this is called middle class. So this is the place where we can say middle class. The middle class person is not able to, you cannot see the rise of the income growth rate with the respective group. But when it comes here, this particular part, this is having increasing. So the inverted elephant, the particular figure says, if up to a middle class you are able to grow, once you reach the middle class, above middle class, then you are not able to increase your growth rate because you are saturated. Thereafter, all your incomes are spent on expenditures rather than savings. So it goes very down. Then after, the highest richest person, this is representing the last 10%, close to 8%. 8% of the top richest person, they are growing very faster rate. So this has been pointed out by World Inequality Report 2018. So now the interesting part is which country people is constituted in this one. You can say India is in the almost top lead, and here also you can see the India mapping. So it means that in India, the top 8%, the top 8% richest people are going richer very faster than any other country. You can see from this picture. So the richest person is going to get more money, and the middle class is stagnant, and lower, I mean, poor people are also growing. But only thing is the middle class is stagnating, and you can see it over here. So what is the link between inequality report and the circularity report? So why it has been given in this particular discussion means this particular dip decides the economical renovations. This particular dip from here to here, this dip is going to decide, because India's developing country, now we can see many families with decent income. If you compare the same story, same geography almost 20 years before, not this many people are earning in the family, but now many people are earning, many people are into software, many people are into abroad. So even in the Pondicherry, there are several families earning more money, but the thing is their income growth rate is not happening. So this particular group contribute huge amount for the economical renovation, and they also contribute for the unsustainable practices. These two things are very important at the stage. Now, when we come to the death rates, like how risk factors are calculated, if you see different reasons for the death, but global estimated death, you can see that pollution is stopping. But when we talk about corona and other places, other issues, we always think that it is very detrimental. But more than that, the most detrimental parameter which leads to death is global pollution rather than any other diseases. So it's all hint that the infrastructure development and human resources involved in the pollution abatement is much serious issue than any other issue. You can see the government input for this particular sanitation and the cleanliness thoughts. The first person of our country, the Prime Minister itself, he has respected. There is no more explanation more than this. Everyone have different opinions, but these two pictures very clearly says how the country is respecting the sanitary workers, and it's a beginning point. There are many things to achieve. The entire thing as in row, but still this is the starting point that we started respecting the human resources in order to the solid waste management. We started thinking about solid waste management. Until Almitra Patil in 1996, if she didn't thought about the waste management, we may not be in the right position to think about solid waste management rules and so many things. After the plague event, Almitra Patil, one lady, now it is now she's not in the limelight for many of the discussion. But to be very frank, she contributed huge in the framing the solid waste management, and she also keep on following the progress of solid waste management in all the all the years. Now, when we talk about solid waste management, it is not a single issue. We cannot select solid waste management as a single pillar to be solved, and it is having multiple problem with that. So initially, it looks like a one issue, then it may lead to air pollution, social unrest, poverty and slum, and greenhouse gas emissions, and wastewater and water issues as also. I'll explain possibly what all way it is getting affected. So this is one important report we should know before getting into waste related topics. So this is water waste 2. This is the global snapshot of solid waste management to 2050. So this is the World Bank report. I recommend everyone to have a look onto this one so that you can understand what is waste related definitions. What are all the waste related definitions? So you can see this particular map shows you how every country's in every citizens in the country is contributing for the waste generation. The color codes, it's very visibly denote that India is in 0.5 to 0.99. So other countries, these are all the places where we have less population, but they are producing huge amount of waste. That's what I said. A population cannot be directly blamed, but population leads to air pollution that we cannot ignore. But individual person is not responsible for that. That's what I just trying to say. So from this picture, per capita waste generation is visible, and this shows that higher income group countries produces huge amount of waste. That's what the picture clearly make it visible. And you can see lower income, middle income, upper income, and higher income. This particular picture, waste generation and the gross domestic products (GDP). So as the GDP increases, the waste generation is also increasing. But the thing is, waste generation and waste management is another important topic to understand. The generation may be higher, but when you think of the management, then the higher income countries have better part in managing the waste. And you can see here, upper middle income country open dumping is very limited in this slide. I mean, particular slide, 30% open dumping for upper middle income, and higher income it is less than close to 2%, and 39 is on other advanced methods. But in the case of low income countries, very less treatment process being taking place, and most of them are most of the waste goes to the dump site. So generation wise, lesser than the higher income country, but the problem management is critically lacking in the underdeveloped countries and developing countries. So there are other issues, special waste. High income countries includes the industrial waste, also the e-waste generation. So this is also mentioned over here, and you can see here kg per capita per day, and industrial waste is higher than any other part of the waste. So these are the basic data we should understand before traveling into the waste related subjects. So global waste composition. Now we are talking about waste, but what waste includes? So here you can see the picture. 44% includes food and grain, and 12% is plastics, and 17% is paper and cardboard. Remaining things, rubber, leather, wood, and all such things are other part of the composition of the solid waste solid waste. First part is the biodegradable. So this contributes huge amount of methane gas emission in case if it is not monitored properly. So the next thing goes is the paper and cardboard. Then we have another important part is plastics. Today discussion is on this particular 12%. And almost sometime it is 12 to 15%, sometimes 30% also increasing. So this is vary from 25 to 12%. That's how I understand from various case studies. To our understanding, we may have more than 6-7 places where we have done the basic assessment of waste composition. So from our studies, we understand that maximum is 30 and a minimum is 10% also the plastics. So this is the plastic percentage in other countries. So you can see high income, the global composition of different waste. And again, the urban is having more kind of food and green vegetable materials than other part of the waste. And plastic is also a major issue. In the coming slides, we will see the things very clearly. The interesting part is this particular slide, which is actually taken from Plastic Atlas 2019. There are two so-called clean countries. They are sending their waste to these countries, like where Britain and America send their plastic scrap. The total plastic exports in seven largest destination in tons in 2018. So this is the data. You can understand it is not that only we generate waste, but the clean countries, they generate the waste and they keep their place clean, and they are sending the waste to other countries also. So this factor to be considered now, thanks to global resource panel. So they have made very clearly, if this particular place, let's say India 121907, this much amount of waste is coming into India, it means that whom to be blamed? The India has to be blamed, or this country has to be blamed. Now the global resource panel has made very clear picture. The material flow, they call it as hot spotting, SCP, sustainable consumption and production. There is a tool available in the online platform. You can find any particular source, any particular material, from where it is sourced, where it is transported, which country it goes. So if India is generating this much amount of waste, then India cannot be blamed. The country which is sending to this country should be accounted for what this country is taking care of the waste. So all these things are involved in recent days. So the thoughts on sustainability is really growing, and it is really making some sustainable changes. But now it is not sufficient enough to realize the complete change. And here, plastic waste generation per person, you can see India is almost close to this particular region, and you can see this particular region which is generating more than 0.5 kg. So if you see the citizen from this geography and this geography, maybe this person have a lot more to blame than this particular person. And what we do with the plastics, whether these countries, what they are doing, we don't have any picture, but what these countries are doing, or holistically what we do with that. So the plastic recycling decoded, that's a report from CSE. They have given this data. 79% of the plastic comes here, goes to the dumping, and not comes here, generate here, including all pictures, goes to the dump 979, and incineration 12 percentage, and 9 percentages go for the recycling. So this is the picture. This is the picture where we need to start. So now the voyage, when we talk about the transport from here to here, what happens in between? There are two things possible. One is the littering travels over the river and other waterway, reaches this seashore, and create a patches. So you can see these big dots and these patches. These represented the actually it's representing the plastic debris in all over the places. So this is taken from underperforming sector right for remake. I mean, there is a plastic recycling report in which we can see these pictures and more relevant pictures. Exclusively, you can see the world in data. There's a website called Our World in Data. It's a very useful website. You can get all global data from this website, ourworlddata.org. You can browse through this particular site. Here, the plastic waste generated is 353 million, and mismanaged and littered plastic is 82 million, and leak to environment is 19 million. Leak to river 6 million, transported to ocean is 1.7 million. So this is the data from our world data sources. And you can see here mismanaged plastics. Say again, you have to understand the previous slide where India contributes less amount of plastic waste generation. But in the terms of global mismanagement waste plastic, we are almost topping here. So you can again, I'll recite the same thing. Generation wise, we are low. Per person generation is low. Country wise, we are more generating. Hello.
Yes, sir, they are giving the exams.
Sorry, I'm not getting. Please. Once again, sir. Hello. Sir, am I reaching you all?
Yes, sir.
Thank you. Is there anything should I say, or any? Shall I continue?
Yes, sir, you can.
Thank you. Thank you. Thank you. Thank you. Thank you. Because online, we may not be knowing whether we are traveling along with the audience, but we keep talking. Huh? Yeah. So I was talking about two stages. One is the generation, we are very less, but in the case of mismanagement, over. I think it's fine. Is it fine? Yeah.
Yes, sir. Yes.
Yeah. So mismanagement, again, mismanagement is keep on striking. So really, we are bad in mismanagement. And you can see the picture here. This is from one of the drain. The thing is, in this catchment area, you hope you understand what is meant by catchment area. The rain occurs in all the places, right? So it is transporting the debris and enter into the drain. The interesting part is the concerning municipality is doing excellently good. They ensure door-to-door collection. Beside the fact, people are dropping the waste directly into the drain, and during the high rainy season, the entire debris enter into the irrigation canal and just clog the entire area. You can see here. Actually, I'll show you all the pictures like composition of this waste we have done. I try to show if time permits all the data. So finally, it's enter into the ocean or any other form of littering environment. So plastic, again, the data is keep on repeating. This particular data I just want to share, because when we talk about plastic, it is more generic. We are not very specific about any particular plastics. So when you really see what kind of plastic is entering into the littering part, that is more interesting, because how to plan for a recycling or any value addition, we should understand the polymer type. So here you can see PET, HDPE, PVC, LDPE, PS. So the most important part is the LDPE. So we should really take care of LDPE, what kind of remedial action it is required, whether we should control in the source or we should control in the usage or we should control in the disposal. So if you are able to control in the source by changing or switching over the replacement of LDPE with any other material, it's well and good. If not, you replace or you trap the waste when the user dispose it. If not, if you are not able to collect it, then you have to think over the disposal point. So this is how the strategies goes for circular economy. We will see it detailing. So these are the different plots which will tell you that if you are continuing to do the same thing, then what happens to the sea? Already our sea is having more plastic particles than the fishes. So if it continues to do so, then how much the pollution will increase? Like business as usual, and if you are taking any remedial action. So these are the comparison of two things, and the most important part again here is a rigid, flexible, multi-layer. So three part is considered in this particular picture. What it mean? Plastic means it's a generic term. How we generally classify plastics? Polymer, based upon the resin identification number, or generally called as recycle number. That is one classification. Other simple classification, you can go to a scrap shop and you have to actually have to learn from scrap shop how they perform the segregation or how they name it. They'll say rigid, they say flexible, they have they nominate based upon the colors. So this is the actual ground reality how they classify the plastics. So this particular study consider a flexible monomer in this color, and out of scope is in this color, rigid monomer in the color, and multi-layers in this color. So different plastics, how it is going to impact on the later environment has been discussed in this. So I'm just skipping it because of time. I just want to show you that these kind of analysis is also existing. We should understand what type of plastic, in what form it is going to create any problem. So Indian scenario, 23% of the total waste generated is being processed and tested. 72% goes to landfilling. India produces approximately 0.025 million tons of plastic waste per day, and it is expected to rise by 34 metric ton by 2031. This is taken from investindia.gov.in. Yeah. Once again, there is a power fluctuation. So approximately 82% of the municipal solid waste was collected and remaining 18% was littered. So this is the data for India, and this is a very interesting picture. This is taken from Global Partnership on Marine Litters, and you can see the data here near around Kadalur. Why I have taken randomly this point is Pondicherry, this particular point, which is showing 5.3 tons per day as the solid waste generation. But in the case of near around Kadalur region, it is not only the Kadalur is responsible, Pondicherry is because it's a waste a water stream. So in the inland, whatever the waste enter, it goes to the nearby river and it reaches the finally the sea. And the World data says that 130 tons per day it is passing through the river location, this particular river location, which is located between Puducherry and Kadalur. So you think about 130 tons per day is being be reaching the sea through a river. Again, it's a modeling. You can see the entire year and how the waste is entering into the stream over the different years. So this is what the picture says. And the next slide is another interesting part. If you drop a waste here, how the waste travels over the distance, like you can see the entire mapping. So if you are dropping any debris in Pondicherry, it travels into 131981, close to 1,31,000 kilometer it transport, and it reaches here. So now you tell me, if I discharge the waste here and it is going to reach over here. So you think about other countries, the moment they discharge the waste, where it goes and where it is going to settle. So this is the problem. This is a global problem rather than a local issue. So entire global community has to take care of the waste. Maybe I'll give you an interesting part. If the country is exporting their waste to this particular country or any other country, we may not be knowing the ocean flow. Again, it will take the plastics and settle over the same country. Also, we may not be knowing about how the trajectory moves with the ocean wave. It may be possible. So, or else this particular place, this particular country take the fishes and again they transfer export to the same country, because karma is very important and it will always alive. So I try to enter now into the Pondicherry scenario, the development of timeline. I have taken one particular paper called the updation of plastic, the waste management in Puducherry, published by Vikram Reddy and Patnaik. That's the base paper to understand how the entire waste management occurs in Pondicherry. So I have taken that paper as a basis. From that, the moment Kalamegam sir was asking me to give a session, I started collecting all the information by inquiring the two municipalities and LAD. So what all the data I have collected, I'm summarizing it here. This particular data, I have really spent more time to get a timeline for solid waste management in Puducherry. So 2010, we started getting into the Kurmambet, and 2015, we have got the Swachh Bharat mission. And 2016, we have got urban agglomeration. Pondicherry urban agglomeration area is trying to have a waste management plan. So they have prepared DBR. I'm not sure whether this data is very good, very appropriate. These are all, there is no recorded document, but by word, I have collected this data. The action plan was to propose to stabilize the Kurmambet dump site. I think, yeah, it's going. So initial estimate for 2.5 lakhs cubic meter of legacy waste. Then 2020, we have got legacy biomining. Then 22, tender being floated for biomining and the capping of legacy waste. Then 23, Vulgaret municipality. And both municipalities are really good, really doing wonderful work. Maybe it is not visible to us because of the quantum of waste being generated, and we may not be interested in knowing the updation of the waste management in Puducherry. To be very frank, as a person who spent more than 15 years in the solid waste management excellently, the recent days we have got a wonderful innovations and innovations in the plastic waste management. There are different privatization parties also coming in. So excellently, they are doing good. Still, we have more to go, but still, what I have witnessed is good. So this is about the comparison from the previous condition. There's 2010 and the present 2024. So it's almost 1.5 decadal updates. So this part, this composting facility operational, this alone I'm not sure about it, but the data as I have collected from the sources, it is showing, but it except this particular part, composting part, the remaining things are as it is. It is factual. So waste generation 370 tons per day, and this is an approximate data for whole Pondicherry, but this is the data which I obtained for Puducherry and Ulgarat municipality. So we can understand huge amount of increase in the waste generation. It is not plastic waste, but it is the waste generation. Then per capita, we are increasing our collection coverages. Now we are ensuring 100%. Source segregation implemented in selected area, but still it has to accomplish. The transportation, now we are really well equipped. We have GPS tracking mechanized vehicles available right now. The processing facility, now we are establishing MRF, material recovery facility. You can visit that site also. It's really functioning very well. Then final disposal, legacy waste management is initiated, and scientific landfill development has been progress. You can witness all the things by you need not to go to the place. You can open the Google map and you can find it. It is visible sometimes. The huge amount of dump is being reduced to greater extent. You can see all the things visibly. You need not to believe the data. You can directly check with the Google Map data. The policy framework, 2016 rules, active implementation in the Swachh Bharat mission. Really, we should thank Swachh Bharat mission, which really made people to understand what is solid waste management. Then community participation, strengthening through Swachh Bharat mission. We have got wonderful projects like Keep Namapandi Clean, and now that is focusing on low value plastics. Now we have feedback foundations, and many more things are coming up. Plan, there is another institution developing a protocol for taking care of waste from the bulk waste generator. A lot of interesting part is coming in Puducherry. Monitoring and evaluation, basic record keeping is, it is really done now wonderfully. The Swachh Bharat mission is enabling all the municipalities to provide the data. There is still not clear data I have obtained from village panchayat. Maybe another presentation, maybe next year I'll be able to present all the village panchayat status on solid waste management. As a person who observe this, this is really good, but still we have more to do. From people's side, a lot of lack of cooperation is being witnessed rather than the administration. So what is circularity? Now we'll enter into the circularity. The circularity is the way to achieve sustainable consumption and production. So this is the sustainability goal which is contributing to the circularity, but there are connection with other goals also. One is resource efficiency, other one is environmental impact, other one is human well-being. So these are the different goals connected to the circularity. Once we correct the circularity, once we work with the circularity, then automatically we'll think of resource efficiency. Then we can think of environment. We can reduce huge environmental impacts, and socially also we can have a lot of balances. So this is what this picture says. The circularity is having a lot of siblings like resource efficiency, environmental impact, and social impacts. So global industrialization, excessive depend upon non-renewable energy sources. This is the preamble for circularity. Why should we go for circularity? And leads to increase in solid waste and climate change. Now, because of this, we call for the strategy to implement the circular economy. So this is the background. Why should we have circularity? And by enabling the circularity, what we are going to realize, 45% reduction in carbon emission and achieve carbon neutrality by 2050. And there are other concepts like net zero and other things, which is not the present scope of the presentation. So next part is the comparison between the existing condition and the circularity conditions. Like if you think of approach, take, make, waste. So that is what we are doing right now. Say for example, any kid is taking a chocolate. We take the chocolate and we throw the wrapper. We take the ice cream and throw the wrapper. We buy the vegetable and throw the carry bag. This is what happens. Take, make, and waste. So what is the circular economy? It requires the concepts like reduce from the source and recycle and reuse. So these are the approaches. So when you talk about resource use, resources are extracted, used, and disposed as a waste. And other circular economy, you have to keep in use as long as possible, extracting maximum value from them, and while in use, then recovering and regenerating products and material at the end of the service. I hope you understand now what is circularity. Then waste generation, if high level of waste are generated in the case of linear economy, in the circular economy, the waste is minimized. Pollution minimized in the case of circular economy. Economical model, it is really good. Sustainable perspectives, a shorter gain, but in the case of circular economy, long-term resilience is there. I'll show you some models people have worked out. I may not be showing the picture, I mean the slide, but I'll show you the report itself directly so that you can go and read it. So this is the strategies: resource depletion, habitat destruction, pollution, waste generation, and increase the inequality. So these are the strategies which we are presently following. We extract the resources, we produce the material, we distribute it, we consume it, finally we'll dispose it. So this strategy is not going to work. Now we are going to switch over to this scenario where we need to reduce, reuse, repair, then remanufacture, upcycle, and recycle. These are the strategies we need to follow hereafter. So these are all theories, right? So every time we are able to hear this kind of strategies, like we have to go for reduce, recycle. But I will tell you, I will show you some reality how the issues are challenging. This particular slide is very important for us to understand where we are standing right now. So first one is spell mistake here: experiment, stabilization, and the diffusion and institutionalization. I'm sorry, I couldn't find the reference. This is not my chart. This is actually taken from one journal, which is presently I'm not able to see, but I think it's missed somewhere. I'm sorry. This particular article, the author has given very clear idea of how the circular economy moves toward. So now we are in the experimental stage. We are not established anything right this moment. So initially, nice innovation, then social technical system, then social technical landscape. So these are the steps we are going to follow. First, we have to find an innovative way changing the people from linear economy to circular economy. So the first thing is cultural changes, technical changes, infrastructure requirement. All these things are very required in the initial stage. Then we have to have a social technical system. We develop a idea, then that idea should be accepted by the people, and technology should be accompanying those ideas. So finally, we have a landscape where the socio-technical things are gelled together, and we can find the sustaining the process. So this is the initial stage. Now we are in the experimental part: science, policy, culture. This thing and technology and market user preference. So these parts are to be worked out. I will explain with a very specific case study to understand how the market user preference, science, policy, and culture and technology should coexist to get into the second phase, that is stabilization. Once it is stabilized, then we go for diffusion. Once it is diffused in all other geography, then we have institutionalization for anchoring, which is the fourth phase. To make you understand what we did recently in Puducherry, I thank to the election department. The election department called the general election process as a green election. They started identifying entire materials being available in the the kit for election process. Really, it is a dream project, because not even we cannot think of such kind of innovation. They started moving all the plastic items into non-plastic items. Sometimes, even if it is a plastics, try to recycling it. Even the food waste, everything was mapped, and finally they have mapped the carbon emissions which comes out of that. So this is one example. Initially, they started experimenting how it works out. Then interesting part is they calculated the total carbon emission. Once they calculated the total emission, they started reducing the carbon emission by planting more number of trees. So the carbon emission comes out of the election process was neutralized by plantation program. So this is a wonderful innovation in the this part, the experimental part, phase one. Once it is done, then the science and the culture, the people adaptation for this particular, say, for example, the entire campaign day, they stopped the banners around the Puducherry. They started accounting how much distance they travel for the campaigning, as well as how much amount of electricity they use. all the material, all the energy, electricity data, then water consumption, everything was mapped. And finally, they said this is the carbon emitted because of the election process. So they had some number to reduce that. How many trees are required? So they planted these many number of trees. So in a due course, it will reduce the carbon dioxide. So this is the idea, and that has to spread across the different geography. Then it become institutionalized, so it become a standard process. This is one such example to make you aware how it can be done. So one is there are different pyramid stage. One is extraction, manufacturing, assemble, and retail, and finally the repair and maintenance. So this is a hierarchy how we should switch over to circularity. So circular design model, then optimal use, then finally recovery model. So we should concentrate on the apex of this pyramid, that is repair and maintenance. So the habit of repair and maintenance is very, very essential. I'm thankful to the former the Science and Technology Secretary Javasar, who gave the permission to develop a pedagogy for school students to do how to do the repair and maintenance. So we are developing a pedagogy for the school students to understand what need to be repaired and how to repair, like your cloth, your shoes and bags and all such things. We are developing it. So this is the seed for circular economy model, how government of Puducherry is adopting for this. Then we can reuse, redistribute. So it requires a communal intervention. Then refurbishments, it requires infrastructure, remanufacturing. In case if it is not repairable with available material, go for remanufacturing. Then recycle it. Then finally, if nothing done, then go for the incineration and obtain energy from that. Finally, it goes to the landfill. Now, these terms are very common to us, but we have to fit into the respective geography. That is what really required for us. So, implementing the circular economy, again, I'm going to critically comment on some of the basic understandings with some case studies. So, be with me. If I'm crossing the time, please let me know, because I'm in flow. I'm not able to understand what's the time and other things. Please correct me if I'm going exceeding the time. Implementation of circular economy, reduce environmental impacts, increase resource efficiency, economic growth, and social benefits. How? The question is how, where to start, when to start. So any case studies is. So this is how we should really work out. This is a holistic data. The entire country is saying like we should close the single-use plastics. Now how we are going to face the changes? Are we prepared? Like the specific region, specific case studies has to be done, and we have to understand whether the region is able to reduce the single-use plastic. Then from the understanding, we have to spread it to other locations. Then we have to stabilize. As we have seen in the previous slide, single-use plastic, this is the first experiment. So let's say one particular place you take, like Pondicherry in Ariangopam or Villanur or Puducherry or Ulgared, any particular place we will take, one particular ward we will take. Then in that particular ward, we will say what is the material flow, how much material enter into the ward, how much material goes out of that, and what are all the sector involved in the process, and each and every sector, how it is interacting with the material flow. If the material flow is disturbed, what are all the way we should prepare for correcting the material flow. This is really required to implement the circular economy, rather than the superficial statement that entire places has to go to circular economy. Though we may debate that we don't have time, we don't have energy and resources, but when we keep on saying so much of policies but finding difficulties to implement, that happens because we are not spending much time, or we are not able to spend time on check the reality before implementing it. So this is very generic term, reduce environmental impacts. Yes, definitely, if you go to circular economy, it will reduce the environmental impact. It will increase the resource efficiency. You are going to save huge amount of resources if you are sending back the material for circulation. The economical growth, by doing this process, you will be realizing huge amount of economical growth. And thanks to Nidhi Aayog, they have developed a wonderful protocol. If any particular municipality is switching towards circular economy, how much human resources they can benefit, how many people get job, how many people can develop infrastructure development. All such calculations have been done by the Niti Aayog, and it is released as a report also. You can find in Niti Aayog website. Social benefit: the circular economy can create more just a equitable society, because if you are dumping any particular place, you are burning some place, the every nearby community is getting affected. I will show some picture on that particular part also. And apart from that, India is known for traditional values. We always worship a river, and we always pollute the river. So this is go line by line. So traditionally also we have a lot of values with the circularity. Now specific part: agriculture, food, textiles, craft, and reuse of the product. So this particular sector specific how we are going to work is also important aspects. Like in agriculture, how the plastics are involved; in food, how the plastics are involved; in textiles, how it is involved; how crafting can be done with plastics. So all the sectors, individual sector, how it is linked with the plastics, we have to work out. So there are other interventions. So I'll get into the national circular economy framework established in India. It's create economic value. It estimated job creation is 10 million jobs by 2050. Projected economic value 2 trillion by 2050. And carbon emission reduction, potential carbon emission reduction is that 40%. I hope you all know about the Panchamritam in UNFCCC COP commitment. Our Prime Minister has committed for reducing the per capita carbon emissions. So these all contributes for that particular cause. So contribution of global climate goals, so 30 to 35% by 2030. If you switch over to circular economy, it happens. The environmental preservation and the reduced waste generation. So if you go for circular economy, the waste generation will reduce by 50%, water conservation will reduce by 20%, and biodiversity preservation definitely is happening. Reduce import dependence and resource security. So most of the resources we are importing. So when you are trying to recycle it, so we will be reducing the dependency on other country for our resources. So before getting into the details of that, I get into the another important part of plastic waste, so that you can understand it very clearly. These are the plastics types. This one. So these are the different types of plastics. So this is a brief story of plastics. We have monomer, we have additives, add together and you'll be getting a polymer. So this is a simple story. Propylene, ethylene and styrene mixed with additives like plasticides, fillers, stabilizers and colorants, and it's all together increase the heat and pressure it and add catalyst, you will be getting the polymer. So the proportions of this have a lot of wonders. We'll be getting different type of material. So the basic thing you should understand is, as long as you procure crude oil, the naphtha which is contributing for the plastic is not going to stop. So we should understand stopping the plastic production is not so good, because we require fuel. So when we require fuel, fuel oil, diesel, and kerosene, and all of the petrol and refinery gas, all such things, if you require, then you cannot avoid naphtha. So the production of plastic is unavoidable. We should understand that. Now, resource been generated, we are going to optimize it. So try to phase out that plastic production should be eliminated. That story is not going to work out. Now the next one, if you are having plastics, these are the generic name we know, but the problem is it is not the general plastic being used in every material, but these are the materials. So this is called engineering plastic. These are the common plastics. It is like a family name, but this is the real names. When we talk about plastics, this particular part, low density polyethylene, milk pouches. Pondicherry itself, one particular brand is produced more than 25,000 milk packets. In Pondicherry, we may have 10 lakh population, and I hope each family have 4 members. If that's the case, let us say 4 lakh families are there. Each and every family have milk packet. At least, let's say 50%. So 2 lakh people purchase milk packets. So 2 lakh milk packets generate per day, if that is the case. So what we are going to do with that? So we have to plan for collecting the milk pouches, so that we can reduce huge amount of LDPE. So every family uses brushes. Each brushes weigh around 30 grams. So if it is, let's say 30 grams. So if it is or 20 grams, they say every family is brushing, then 20 gram into the 4 members in a family into the one. I mean, 1 year if you are using 3 brushes, so 3 into total number of families into 20 gram. That much amount of plastic would generate. So that is how we have to look on specific product strategies. So in India, 15 largest polymer manufacturers are there. These are all taken from Plast India. 40,000 plastic processing unit, 7,000 recycling unit, and this is the total picture. Only 15 large polymer manufacturers are there. From them only, we are getting huge amount of plastics. And you can see the picture of whole India, where and all we have plastic processing units. There are other more details. I'm leaving it. Value chain in the plastics. How to establish fractional distillation, naphtha, then polymerization. It comes to the polymering compounding, plastic product manufacturing, packing, then consumer usage, discarded, then collection. So again, it goes to the plastic manufacturer. Then they use the small portion and they recycle it. That is how we are going to get the circular economy. So this is the another important fact we should know. When we say plastics, try to understand what type of plastic it is. The one important part is fast moving consumable products. They call it as FMCG, fast moving consumable goods. So what are all the goods available right now? We have pulses, cereals, then edible oil, dairy, then packed food, then home personal care. So these are the different materials which is considered as fast moving consumable goods. So plastics in this particular FMCG, this is actually contributing huge amount of plastic just leaking into the drains. So we have three categories. One is food and beverages. Three category, you can see huge amount of tablet packets and used ointments and several other paste which is used for our health care. All the things will be discarded. The home and personal care, huge amount of personal care products. You can go to the beach and you can see all such things. Food and beverages, nothing to say. We have huge amount of plastic generated in the plastics. It is not only environmental issues, it's also create health impacts to us. So what are all the food beverages? Milk, instant coffee, blend spices, all this ketchups, salty snacks, chocolates, and all such things. So these are the material which comes under food and beverages, and these are personal care. These are the home care products. Now the interesting part is 10 gram or 10 ml packet is more. You can see this is considered as a sachets. If I show you some pictures from the drains, you can understand like huge amount of 10 gram 10 ml packets are found in the drains. So those are the product of fast moving consumable goods. Say if you're say in any particular institution, let's say education institutions, there 5,000 people are studying and the assume 1,000 people are taking biryani per day. If that biryani is served with one particular jam packet which is having 10 ml, please try to understand every day 10 ml sachet packet, which is considered of 3 inches and let's say 4 inch and 3 inch width, that much amount of plastic generated every day. So 1 week you have 700 packets, 7,000 packet, and you can multiply with any number you like. So sale value and unit sold, this is you really should understand. Sale value means if I am selling 100 rupees, if I sell 100 rupees one particular packet, only less amount of plastic is generated. But for 100 rupees, if I sell 100 packets, each packet, like say shampoo, if I purchase only one bottle of 1 liter for 100 rupees, how much plastic I would generate? Only one rigid plastic. But if the same company is selling 100 sachet packet, each sachet is having 1 rupee, then I'm going to generate 100 sachets for the same value. So the customers, the fast moving consumers, they wish to have the handy packet, and that contributes huge for the plastic waste. So this is one important thing we should understand to get into the circular economy. You can say home care, personal care, and food and beverages. So these are the different sale values up to 10 gram. You can see here home care 10 grams is 2%. and 15% and 72%. You can see here more than 1,000 grams comes at a 72 grams. So for every sectors, how the things are distributed, all this data can find in the Plast India. So all the plastics is not floating. We may be misleading that all the plastics are floating, but it is not so. Only very less percentage, less than, I'm not sure about the number at timely, but some amount, very less amount of plastics are floating. Remaining things are going to sink. So high density plastics like nylon, acryl, polycarbonate, polyethylene, terephthalate, polyvinyl chlorides, which is having higher density, is going to sink on the sea floor. So if the sea floor is having some floating material, we are afraid of floating material itself. But on the water table, on the sink, a huge amount of material. Then recent days, you are able to see some pictures of black plastics, especially food contacting materials. There are stories from CSE. There's an article being published. The e-waste recycled plastic is also mixing with the mainstream plastics, and the flame retardant added in the plastics is also contributing in the food packing material. There are few cases, obviously we cannot avoid it, but that the recycling of plastics having certain limitations, especially with the food grade plastics, sometimes it happens. I'm not going to detail it, but still I'm just sharing some incident about recycling issues or limitations. So this one is a bottle. You can have cap, you have liner inside, and we'll be having glue, adhesives, or labeled over here, label, body resin, colorants, barrier, additives. So try to please understand one thing: when the water bottle kept at the sunlight, it may not be fit for drinking, because the UV retardant, if it is not there, then directly the sunlight is good enough to create interact with the plastic, and it will release some amount of component into the water. So they keep it very clearly in the label, avoid sunlight or something. If that has been mentioned, make sure that polymer is not good for contacting the food material. So how we are going to handle that's also gives the health impacts. Now the issue is, if these many additives are there, when you are recycling it, each and every component have their own responses. So there where the problem comes in. So and another issue is the cap is having different polymer. This is another polymer, this is another polymer. I repeatedly say when opportunity comes in, this is HDPE, this is polyethylene, and this is PET. Each material have its own recycle value. So we may not be able to treat everything as same. So the remedial issues, you can have labels of different kind. You can see here in this picture, like you can have remedial design like this. Instead of having the cover like this, you can have a seal here to ensure the quality of the brand, and you can reduce the branding label size also. There are different strategies you can get into the circular economy. I hope I am able to make you understand how the things are getting into the shape, but I'm not sure about the time. I think it is crossing. So one small case study I wish to share with you, how they have developed it. Please bear with me for a few moments. There's a place called Croatia. They have developed. This is how we have to work on region specific and one particular aspects. So they have calculated one particular region for one particular region, what are all the environmental impacts occurs. So you can see here. So this is they call a sunken key diagram. So they have got all the resources which is entering into the city, and for the particular city, what are all the aspects they're going to control the material. So you can see here: agriculture, food processing, quarrying, quarries, minings, then manufacturing industry, utility service industry, construction industry. So these are the different industry. These are the resources. You can see what are all the resources: minerals, ores, fossil fuel, biomass, and recycled material. These are the resources. These are the applications which is requiring all these resources. Finally, this is the outcome. One is the extraction. These are the social needs. This is the requirement. For Pondicherry, what is the requirement? What is the material which is entering our region? Through what source it is reaching, and what is going to give out of the resource utilization after the societal need, what is going to come. So from this we can model it, and we can say this I can stop, this I cannot stop. So that kind of strategical policies and implementation is required at this stage. So until we don't do that, it is very difficult for us to realize the circular economy. So you can see here, these are the sectors: agriculture and food, mining, manufacturing, plastic and packing, construction, mobility, waste management, furniture, woodwork. These are the essential material for the city. And when we are using it, then we will be able to monitor how plastic is involved in all these parameters, and how we are going to control it. Say, for example, agriculture, we control what is alternative material. So if I go for alternative, what is the impact of the alternative material on mass, carbon, and the value on the waste? So this is how we have to go for strategies. And this particular region, they have done a wonderful case study, region specific and the sector specific manuals they have given, and they have summarized also. If anyone is interested in government agencies, if anyone is interested in getting into the circular economy implementation, please kindly follow this particular guidelines. They have given a list of items, they have given what is higher in priority and what is lower interest. So we have to divide the sector according to this picture. Then we have to prioritize it, for which we have to make policies. I'm done. Thank you.
Thank you, sir.
Yeah, thank you. If you permit, I can show you one case study recently we did in the Puducherry region.
Yes, sir. Yes, sir.
Yeah, thank you, thank you. So this is a recent study we did in Kottagopam, because everyone knows this is a very interesting study, a risky study also. One of my students was involved. So what we did was, there is a dump site which is burning all the day. So we understand the problems associated with that. So we use these many tools which are relevant to the solid waste management. If time permits, some other occasions I'll explain that. So what we did was, we tried to collect the data from all over Pondicherry. Ganganal is a student name who collected every month once. He collected all the dump sites from Pondicherry University till Kadalur. So we have located close to 54 dumping locations. You can see the land lot, and these are the sensitivity of those dump yards. So totally close to 54 sites we have located. Then we have got very serious dump sites and critical issues. As you can see the growth of dump sites here. And we have inquired with the local people how it is controlled, how it is started, and all such stories. This is the Kottagopam story. So now we can see this is being closed. So it's really, he worked a lot, and he understand how the pollution travels around the city, around the places. It is not that the Kottagopam people is going to get affected, but the people near around will also get affected. We have used some models for that, and we have calculated, and we have also did the SDG 11.6.1 to quantify how much amount of waste has been generated. We also monitored how the vehicles are moving and collecting the waste. Then we also monitored how the waste is leaking from the individual houses. So this is the, why I'm showing this is the basic work we should do for implementing this circularity. So we have done extensive work, close to 3 months. These people work day and night to collect all the data from Puducherry and other nearby regions. Then we have calculated from satellite-based data. We have calculated emissions from individual places also. This is the circularity report. I said how much amount of employability we get out of implementing the circular economy. So this is the design strategies given by the this agency. They have given MHUA, Ministry of Housing and Urban Affairs. So they have given manual for circular economy, municipal solid and liquid waste. Based on that, how much amount of job we get, that also we have calculated for Puducherry region. And another one place was keep on burning all the time. So one of our student, Mr. Praveen, has done a wonderful work. He collected all the waste, I mean all the day, and he tried to model that with a tool, and his wonderful results we have got out of that. So this is the that particular case study. So he used RoboFlow. There's a tool called RoboFlow which is useful for image processing. So this is one such example you can see here. So this is a dump site. From that, we took a picture from the dump site. We have processed what all the material present over there. So he developed a tool which is already existing, YOLO style boundary boxes. So from that pictures, he is able to identify the items present over there. Then what are all the percentage? We physically verified in the field also with the help of Ulgarat municipality. Really, they worked hard, and commissioner and Jai sir and all of the team, the entire team was so cooperative. So they have helped us to calculate all these things. So we have calculated what all the fractions present in the dump site. So this is one particular example I thought of sharing right now. This is near ECR. Every day this cow is subjected to this amount of emission, all the plastics being burned every day. So we have calculated from October till April, October, November, December, January, February, March and April. For all these months, we have taken picture of this particular cow every day. Collectively, we are able to get the pictures which is of 83, and now we have started 54 samples. 54 days we have captured this cow is inhaling this particular fumes. Every day it is fuming. So what we did was we used some of the toxicity tools called USTOX, and we have calculated how much amount of emissions comes out of the plastics. We also taken picture and previous photo what I have shown you from the same dump site. We have classified the items present in that. Then we have calculated how much amount of emission based upon the emission factors. Then we have projected the possible emissions, and it is being subjected to that. And addition to that, it is not just a cow which is going to get affected, and how the pollution is going to transport from this place to other places, for which we have used another tool called Mira, and from which we are able to understand where it is going to get transported. That also we have worked recently. So with this, I'm closing the session. So thanks a lot. Thank you, ma'am.
Thank you, sir. Any questions from participants?
One more alarming thing is one of our student who worked on bedroom ACs. Shockingly, we get to know huge amount of plastics, microplastics being found in the ACs, which is kept in the bedroom. So we have collected close to 16 samples in around Pondicherry. So the AC filter dust was taken, and from the dust we have found a huge amount of microplastics, which is really alarming. And the sources for the microplastics are from the bed sheets and cloths, screens, and all such things. So huge amount of plastics being occupying your bedroom also. I really alarm you. There is a issues, and there are several articles which says that our respiration rate is also correlated with the microplastics presence and enter into our respiratory systems. Yeah, any questions? I'm happy to share. And one more project we did, Tamil Nadu Tennambakam temple. It's a very interesting work. Almost 4 years we have been doing. Now this year, interestingly, the Tamil Nadu government also came forward. The additional collector, who is our alumni from Pondicherry Engineering College, she cooperated a lot. She took forward this particular project, and this year we are able to save huge amount of plastic. The entire team, the Swachh Bharat Mission team from the DRD office Cuddalore, really helped us a lot. We have presented, we have completely studied this. These are the issues as we have pointed out after 3 year studies. So the entire temple accompany more than 4 lakh people. Then we have studied, then we have presented the report. These are the things we have presented. Then DRDA is good enough to consider this issue, and the additional collector came forward and she visited the place, and the entire village cooperated. But still, the visitors, so the so-called, I cannot say openly, but the devotees who come around the place is spoil that entire region. Beside the best efforts being taken by the DRDA people, and these are the photographies which we have conducted study over those places. So really, academies as government is doing wonderful work, but unfortunately people are not able to cope up with that. I humbly request you all, when you go for the temple especially, please take care of the environment, because some of the places are very precious. These places especially, this is very near to good ambience, where you get a lot of trees and good water body, but people are polluting very, very worstly into the environment. And we have conducted a study. After conducting study, we understand that this is very uneasy. So this is the results we got from emission factors. So these are the things we have taken the photography from in around the region, and we have identified the plastics. And if it is burned, what are the emissions and how much people is getting affected. So you can see here the toxicity assessment compound from open burning of the waste using the toxicity. These are the two tools we use for estimating the emissions. This is a pani puri cup. I'm again I'm underlining this. When you're using the pani puri cup, please make sure whether it is fit for consuming or not, because most of the products, there are many studies we have done, even the spoons we use for carrying the pani puri, there is no composition present over there. So please beware when you are using plastics for that. And our problem is when you are burning it, this much amount of emissions are directly come out, and it's all highly human toxic. So when someone is burning, don't think that it is somebody's problem. The fumes comes to you, and you will also subject it into a huge toxic impacts. So thank you. Thanks for this opportunity. I'm interested in sharing all our studies because academics should go in line with societal demand. So most of my works, my students really do a lot of field works, and we require the document shares with the public. So what all the work we have done, what all the documentation we did, we thought of sharing with the public rather than publishing in a scientific journals, because no one is going to take action based upon the scientific journal when in the local problem is mounting. So we thought of having a media like this to share our findings, and we have to get the feedback from the people. So we have got something called citizen science, which is we name it as Purpose, Puducherry Urban and Rural Sanitation Endeavors. So through Purpose Citizen Group, we try to get feedback from the people, and we also share what are all the things we studied out of them. So a temple festival and cultural festival and schools, for example, all the places we really require a lot of innovation. There are a lot of potential for circular economy is still alive. So any more questions? I'll be happy to have any questions. If there is no question, I will ask you one question to all. Please send me the response. That will be helpful for me, because right now we are working with a toothbrush. So what, how you are going to discard your toothbrush? You can give the answers in the chat box where you are going to discard, like in a dump, in a bin, or you are throwing somewhere. You whether you don't know or not. Maybe you can collect the email ID if possible. I will send the question. Please send to them, because they don't have question. I have questions to them, so you can take the question and give the response. I think Dinesh is here, so he has done a lot of beach cleaning program. He found often brushes, pens, and other things, markers, uh, brush caps, and all such things. So thank you, Kalamegam sir. I think sir is not here. Ma'am Santalakshmi, I'm done. If you have any other questions, you can always feel free to ask.
Thank you very much, sir. Your case studies and the research works were very interesting and informative, sir.
Thank you. Thank you.
Okay, sir. No questions from participants, so we'll wind off this webinar with the vote of thanks, sir.
Thank you.
Okay, sir. So, good evening to everyone. On behalf of the Puducherry Climate Change Cell under Department of Science, Technology and Environment, I extend my sincere gratitude to all the participants for joining today's webinar on circularity in plastics, the key to ending pollution. A special thanks to our resource person, Mr. S. Surai sir, for his insightful presentation on the topic. His insights on sustainable plastic management, circular economy principles, and practical strategies for reducing pollution were truly enlightening. The real world examples and the policy perspectives shared were very both informative and inspiring toward a cleaner and sustainable future. Thank you, sir. I also
Thank you.
express my deep appreciation to Thiru Kalabegam sir, environmental engineer at DSTE, for his opening remarks. Our heartfelt thanks to our department director for his unwavering support and encouragement in organizing this webinar. Finally, I extend my gratitude to all the participants for your engagement and their contributions. Let us take forward the insights gained today and collaborate towards a resilient and sustainable future for Puducherry. Thank you all. Thank you, sir.
Thank you once again. Usually we say no, like a patient listen. So it's everyone is so patient enough to listen to that. I think they switched on and left off.
Yes, sir.
It happens. No problem. Thank you.
Okay, thank you, sir.